Murray is he's a consultant with Cantor Consulting LLC, and the two of them have a joint talk here for combining joint costs and schedule risk analysis with earned value management. And you two can take it away.
Okay, thanks. This is Christian. There's Christian Smart. So this is our talk about combining joint costs and schedule risk analysis with earned value management. And this is an issue. I think we go to the next slide. I think Murray, you're presenting? You're sharing your screen. We go to the next slide. So this is a problem that I've been wanting to solve for a long time. I was been doing cost risk analysis for a long time, and customer and I said, well, how do we update this? Because we were between milestones and we were getting some information in the way of earned value data about how the contractor was performing. How can we update? How can we adjust this? And so I didn't have a good answer at that time, but 2 years ago, I ran across Murray on LinkedIn, and he had this paper on Bayesian parameter learning that he was basically describing something a solution that problem I've been trying to solve for a long time. So this is perfect. This is what we need. So he and I connected, and we've been writing together for a little while about this topic and working on a book together now. But anyway, so the key thing here is innovation fuels uncertainty, and that's the origin of risk. Uncertainty is the indefiniteness about an outcome, and risk is the bad things that can happen. There's a lot of risk in novel projects. Things that are been around for a while that are in sustainment aren't as risky. Things like, the M1 Abrams tank and the littoral combat ship. But the things that have some more novelty, Joint Strike Fighters and operations now, but it's still very expensive. And then the things that are quantum global positioning systems, quantum computing, fusion rocket engines using nuclear power. Those are very novel. Those things have a lot of risk, a lot of uncertainty, and a lot of risk. And aerospace projects in particular often require technology development and can take many years to develop. And so the longer it takes, the more things that can go wrong, the more risk. Okay, next slide.
Sure.
So the problem, though, is in terms of understanding risk and analyzing risk is stovepipes between different organizations. So you got project management, you got business planning, you got cost estimating, schedule, earned value, risk management, and all these folks don't always talk directly to each other. And there's lack of an objective way to kind of bring these two together. So earned value is kind of going off and doing something. We're going off and cost estimating and doing something, but we don't always work together. We need to collaborate. Go to the next slide. And then, there's uncertainty, we need to have communication, need to address the earned value enforcement and as well as other stakeholders. And we need more rigorous and truly probabilistic, techniques that have a good foundation in statistics and mathematics. Next slide. And we need to change the way the communication works. Set the expectations for schedule and cost. Look at the deadlines, and work on prioritizing scope and schedule, and looking at the whole range and working together. Okay, and then over to you, Murray.
Okay, thank you. Let me see. Should I turn on my video? Does that work?
We see it.
Okay, how about that? Put on a good shirt and everything. So here's the key idea here, that uncertainty itself is a first order kind of concern. As Christian mentioned, if the bad outcomes from uncertainty are risk, the good, but the opportunity, on the other hand, you might actually exceed expectations, and those are a kind of optimism. But the key idea here is that risk and uncertainty itself should be managed as a first order concern. And that's just following the standard Kelvin quote that we use often in any kind of management, that if you're not measuring something, you don't know enough about it to manage it properly. And so what we're presenting here is a method for measuring the uncertainty of costs in the schedule. This has been known for a long time, but the current idea here is not only do we do an estimate at the beginning of the project, and then that's it. We're going to continue to update. We're going to use the actual experience inside the project, observations about how the costs and completion rates and costs, completion rates, and so we have in terms of time and cost, in order to update these, use Bayesian techniques to update the initial estimates to get a clear idea. Now, one of the key idea here is that, again, there's uncertainty at the beginning of the project, and what should happen as we proceed along the project, as we're continuing to evolve, in order to do innovative things, you have to assume a fair amount of risk at the beginning. No one's going to do quantum computing knowing quantum GPS, for example, quantum computing, or the hypersonic engines, embark on that project thinking they fully understand everything there is to do, and so they can be they have all the information they need in order to do firm estimates. In fact, they're going to have uncertainty at the beginning. What we want to do is, at the beginning of the project, we assume that uncertainty, but by the day we ship, we should have no uncertainty at all. So what has to happen is, in between that time, the cone of uncertainty has to decrease. We want to measure that explicitly. Now, the other challenges we have, how this technique is different than some others, is we have very small data sets. The idea is that in any given task, we have the completion rates, the costs that it's taken to do that task. By the time you roll up so you have a small data per task, per work item, and then as you roll those up across the whole project, you're actually rolling up a lot of small data PDFs as we go. And so we want a method that will work, that doesn't assume asymptotic methods, doesn't assume big data management, but we want to work with small data because that's the kind of data we have. So what we've done is, in order to address these concerns so that everybody can be on the same page, is we want to have a very credible, mathematically sound way of everybody buying into the same techniques. So we want to get past the ad hoc techniques, such as those used in agile agile velocity, or this kind of rules of thumb that you see in various correlation methods. And we want to have a technique that everybody can buy into. Now, what we're going to do with these techniques is we have at the beginning, you have estimation techniques that may simply rely on expert opinion and 3-point Pareto estimations. But what we want to get using, as I said, the actuals, with small data actuals, return the probability curves that people can use in order to decide if their uncertainties and risk are actually decreasing or increasing as the project continues. And if they're increasing, be able to take action early on and avoid the green red effect you often see in project management. So the key, and so we have an algorithm here. I'm not going to go through it all. There's white papers available, but the key idea here is what you need to learn is the velocity of cost and of the EVM parameters of the cost and of durations that it takes to do tasks. And what we show in the paper is that the initial estimates can be recast as velocities, and then you use and so for example, you can use your standard Pareto estimates as priors for your velocity measures, and then you update those using parameter learning and grid methods, and then to get the individual task parameters, task time to complete, cost to complete, and then you roll those up using Monte Carlo simulations to get those for the whole project. Okay, so that's our solution. It's a combination of risk analysis, because you want to, and risk management. You want to include the, and it includes the, so we're including the probability of risk events and how that affects the time to complete and cost to complete. So we're integrating risk management and risk analysis together. It uses data you already should have, but often people don't collect. So this is one of the challenges. So the point is, you should have at least initial estimates. Either you get those through parameterized methods and the kind of techniques that Christian has been fostering and promoting for quite a while, developing with us together. And then you want to track the actuals of costs and estimates, because that's what how much you're spending, how much time it took to complete a project is actually required for earned value analysis anyhow. Now, often people don't track those in projects because they don't get any value from having done it. And this is going to be one of the challenges we're going to talk about later. But the key idea here is that if you actually track your actuals and estimates, not just for UVM purposes, but for project management, you get a common view of everything. The UVM people are in line with the project management people. All of that can be together with the risk analysis people and the risk management people. So we have a common view of everything. The kind of views we're going to get are shown in this kind of, in these displays here, which is if you look at the time, you use our algorithms to get the estimated time to complete or estimated cost to complete, you get these kinds of distributions. They tend not to be symmetric. And they're not actually, and they're not parametric. They're actually empirical because of what you learned from the Bayesian updating, not and the like. So even though we estimate, what we do is we combine location and scale parameters in a way to get those we treat those as uncertain variables. So we get PDFs for the mean, PDFs for the standard deviations or whatever. Then we combine those using Monte Carlo analysis to get these kinds of empirical distributions. And there's two ways we can look at that. We can look at that as the red area, the uncertainty of the risk of meeting the target is the red area in this PDF. Or we could look at it in terms of what is often called S-curves or cumulative distributions, where you see what the probability is of making the target from these as well. Now, the key idea here is we're learning velocities. We use Bayes' theorem to update the initial velocities with actuals. And again, we'll have white papers available. So there's two ways to visualize the uncertainties that we come up with. One is the one we showed you before. What is the likelihood of making or beating the target? Here's another example. Or if you're going to miss, how much are you going to miss by? And so that gives you the percentile view. So this is the target view. This is the percentile view. And so in fact, you might discover you're 90% likely to miss the target, but only by 1 day. Well, you don't care much about that. So you need both views that come out of the algorithms. Okay. So again, other things you can do, for example, you can look at, you want to be tracking both the cost and the schedule uncertainties as you go forward. So part of what we're doing is building on the joint cost and schedule approaches where we take, you may use a scatter plot to get your initial, to choose between your probabilities. And then these are your priors, but these things tend not to be updated with the actual team performances once you've chosen a project based on these scatter charts. So you get a view that can look like this, where each point, so this is a tracking view and this is a portfolio view. So let's look at the portfolio view first. here's a bunch of projects of different colors, or show them, and the ellipses around them show the uncertainty in cost in the horizontal, and vertically shows the uncertainty in the schedule. So for these particular projects, you're fairly certain of the cost, but uncertain of the schedule, and the others are different. Have the different thing where you have uncertainty of cost, but you're more confident in the schedule. And you can have one this one's here is we're very confident of the schedule, but the cost is quite varied. This might be because of cost of materials or some sort of dependency that you may not know about, that you may not have much control over. Another view, project tracking. This is a single project with a view of each color shows how the remaining residual cost and schedule risk, depending as the periods go on. Now, what happened in this schedule is that we got to a certain point and then realized that we had to do a baseline change. And so at period 4, they decided to update the schedule, and so we left this set of embedded ellipses and ended up with this set of embedded ellipses because of the replan and the rebaselining. Now, these are interesting theories, but the theories aren't all that useful unless there are tools. So the tools are emerging and becoming available to the market, and I wanted to talk briefly about those. So as I said, we have developed this algorithm. Christian and I worked on this together, but this is, and then we've created these algorithms and made them available to the Intervert Institute as a add-on. So these are now being implemented in the risky project project management tool, which combines risk analysis and risk management already. But they've incorporated these Bayesian methods for their next release as a predictor module. Right now, it's doing time to complete. This is going to be available like within weeks. And then we're going to work on the cost to complete and the total portfolio view for the next release, which should happen. It's hard to, well, it's not mine to predict for them, but the goal is to have those available by the end of the year. As I said, the Intervert people are going to be publishing a version of this with a module within the next few weeks. And also, if these are pretty heavyweight tools and they're suitable for very large projects, we tend to have like maybe 1,000 work items in these things, and they'll scale up to that because of the way we've implemented the algorithms, or in particular the way they've implemented the algorithms, converting my Python code into C++ to get the performance boost. But also I can, if you want to have simpler versions or more tailored versions or whatever, these are available directly from me. So I have code and I can implement these and tailor them to your environment. So finally, actually, I'm going to hand this over to Christian, but what we both agree on is that this isn't going to be simple. I'm going to talk about it briefly, and then Christian will talk about it more, I think. But the idea of breaking stovepipes, developing more of a community, means that you really are going to manage differently. And you're going to have a better kind of communication and more transparency, but the organization has to become used to doing that. And so one of the things that is going to be a challenge for people like NASA and whatever is integrating the stovepipes. This is a good thing, but but will involve a different kind of management. So Christian, why don't you take it from here?
Yes, exactly. Yeah, thanks, Murray. So that's exactly right. You need to kind of change things. Maybe. Can you hear me?
We can hear you.
Okay. We need to change things. You need to work more closely together, that sort of thing. The key analogy is, cruise missile rather than ballistic missile. We're not just taking aim and then walking away. We're steering it towards the target during flight. We're changing the measurement of uncertainty in project's development. It avoids the problem of we're looking good, now we're not looking good all of a sudden. So trying to get warning early enough to take action and provide better estimates than other commonly used agile velocity measures. And it's a rigorous mathematical approach. It's enhancement to things that are just currently ad hoc, currently done. Cost estimators, we go off and do something, and then earned value people, they go off and they do something else, and then there's a disconnect between the two. So this is a way to a bridge between the two approaches.
Okay. Any questions, anybody?
I don't see in the room online any questions. If you into chat and Zoom. If not right now, thank you both for very interesting for this talk.